Well, hello and welcome. It is time once again to try to fix something. Today on the workbench, we have yet another dead PS5. Yes, they are my favorite. And that's usually the way I look for them. I look for dead ones, totally dead ones. And this one is definitely totally dead. I do have it plugged in, no signs of life whatsoever, and that is what I prefer. It doesn't always work out for me, but I seem to have best success with those. So let's get the covers off of it. Let's just see if it's been tampered with or not. Well, the side plate is off, and a little bit of dirt on this one. Not too bad, but take a look at that. The security tape's still intact. She is untouched. Excellent. All right, let's just see, get on into it and see why it's so dead. Well, I have removed another cover. We're a little further in, and we can check for 12 volts now right on this connector, 4-pin connector for the Blu-ray drive. I believe we should have it right there on the top. Yeah, I don't think it's on the bottom. No, I believe it's the top pin. We have nothing, no 12 volts. So, but if I check, I don't seem to have a short on that rail. Yeah, I'll unplug the power supply. I don't think it's gonna make any difference. I don't think there's anything there to worry about. Yeah, there doesn't seem to be a short. So, I don't know what it is. Let's get a little further into it. Well, I had started removing the 5,000 screws around the perimeter of this board when I remembered I hadn't even tried swapping out the power supply. So that's what I've done. I've taken out this supply and put my known good spare one in there just to see if we need a supply or not. And let's see. We do have 12 volts now. We do indeed. Will it turn on? It will. Is that all this thing needs? Is a repaired supply? We're getting video. It's thinking about it anyway. Maybe. There we go. All right. So we just needed a replacement power supply. So we'll just throw this one in the garbage, put this back together, call it a day. Nah, we're going to try to fix that power supply. We're going to try to fix this power supply. There we go. Beautiful. All right, we'll get this power supply inside and see if we can make it work again. Well, here we are inside the workbench, ready to take a look at this power supply. See if we can make it work again, so I can keep my spare supplies. Because I do like to hang on to them. Let me get rid of this antenna. I am seeing some slight signs of roach activity. Very slight. I don't know if that's picking up on the camera. Anyway, just maybe there's nothing to it, but very slight signs of, what I would consider a signal that there's a sign there's roach activity. But if there is, it's very, very slight. Didn't really notice anything in the chassis of the PS5, but they do tend to head right toward this power supply. I suppose because it's warm. And this, once again, is the part where I remind you not to open up your power supplies, as there are dangerous voltages inside. There we are. That was easy. That really is, getting these open is a lot easier than, say, a slim power supply. These things are a beast to get open. Anyway, let's go ahead first thing and discharge these large capacitors right here. Nothing. Huh. That's surprising. No charge. None whatsoever. Oh, yep. Well, I think we see what happened here. Something did make it into this power supply and may have just blown the fuse, depending upon where he decided to crawl. You can see the little scorch marks right in there. Did he just blow the fuse? Now, I don't believe I've ever been that lucky that a roach just blew the fuse. Let's just see though. Continuity mode. Okay. Did we just blow a fuse? No. Did we just blow a fusible resistor? Get this on up here. The fusible resistor right here. No. Oh well, we didn't short the output. No, we didn't read a short. We didn't read a short out there when it was plugged into the chassis. So fuse good, fusible resistor is good. So I'm assuming these MOSFETs are probably good. If they had shorted, it would have, you know, if these MOSFETs had shorted, it would have blown this fusible resistor very fast. So did we burn a trace open? Did we burn a trace open? That happens sometimes. So we should have conductivity all the way to like this bridge. This should be the bridge rectifier really right here. Yes. No short there, of course. May have to look under the microscope, or I can just see, you know, scorch marks right there. And there may be a blown trace right there. Maybe a blown trace. All right, let's look under the microscope. Wake up, Mr. Microscope. See if we can get it. Oops. I keep accidentally adjusting my microscope when I don't mean to. And now I have to adjust it and get it back right. The distance between the eyes. Okay. Well, we've made a nice crater into the board. But I don't believe we burned open a trace. So we shorted. Let me check with continuity mode. I want to say where that's connected. Where you see that 7.5 megohm resistor. That is connected to the main filter caps. So there's potentially a lot of voltage there. I'm going to put one lead on the plus terminal of one of these large caps and check right here. No, it's not directly connected to it. So is this common right here? The negative side of the filter caps? No. Which obviously a common of some kind. obviously a jumper right here. These resistors are very hard to read in a circuit, by the way. They're such a large value, and there's some other paths. So let's look where this goes. Yeah, we've had trouble in this area before. This is going to connect down to the DAP53. It's going to come down through here, under here, under here. There's going to be a Zener. It comes through here, and I believe splits underneath these resistors, or between these resistors right here. And if I'm not mistaken, goes to this Zener right here. Let's just check that. Yes. So, yeah, we've had this. This is an 8.2 volt Zener, as best I can remember, which limits the voltage into this DAP53 right here. So anyway, could have lost the DAP53, but I kind of think what happened is this voltage went somewhere it shouldn't and damaged something else. I mean, we can check. Like, we're not shorted to ground at this point, are we? Let me get on the negative terminal of that capacitor. No, there's no short to ground right here. Trying to remember the exact path for this. I mean, I've been in this circuit many times. Oh, I did notice something there, if you can see it in the light. There's a slight hole in the DAP53. It's just a small one. It may not be important. Yeah, I think the magic smoke has escaped from the DAP53. I've always heard that electronics operate on smoke, because once the smoke comes out, it doesn't work anymore. Yeah, that's what I heard anyway. And the magic smoke has come out. Okay, so we need that. Is that it? I mean, we need to do a little work right in this area, looks like. Left a pretty good crater. Clean that up a little. Maybe we just need a DAP53. That would be good. I am wondering. Maybe that's all it is, but I wouldn't bet on it. Well, our DAP53 has been changed out, and I think we are ready to test. I've got my DC load connected, hopefully the right way around. If I can get that to focus. Yeah, I think we're right. Yeah, negative on the right, plus on the left. Okay, and then, so let's see. Load is set for 10 amps. It is on. I am going to bring the AC voltage down, and I'm going to ease it up slowly. Let's see, I'm just going to bring it up slow. We're going to see if she will start coming up or start smoking. Oh, it's trying, but it's shutting down. Let me turn the load off. See if she'll start with no load. No. Watch it. Yep, we have a problem. Have a short of some kind. Tries to start, but it goes, oh no, I'm shutting down. Still have a problem somewhere. All right, well, I turned it off and checked the voltage across this capacitor, and it was over 480 volts. So yeah, that's a problem. They're only rated at 450. So our power factor corrector circuit is running wild. It is running absolutely wild. I have discharged the caps now, so it should be safe now. But let me check it again just to make sure. But it's 13 volts across it. So our power factor corrector is not doing what it should do, or it's being an overachiever. So most likely we have something damaged in the feedback circuit for the power factor corrector. And those 7.5 meg ohm resistors are in the line. They are a part of that feedback. But like I mentioned before, it's impossible to check them in circuit. Oh, I just noticed something. Yeah. We've had this trouble before when I've worked on these. This little MOSFET Q34 right down here is in that same circuit. It's hooked to that same point, and it's blown to bits. Yeah, it's blown to pieces. Not sure how well that's going to show up on camera. Not at all. Not at all. She's blown to bits. We can change that out. I still wonder if that's all of it. If that being bad should just make it like shut down, not run wild and generate way too much voltage. That's not what I would expect. Let me go to diode mode and look around this replacement controller here. Pin 1, 2, 3, 4 is ground. 5, 6. 7 is no connection. 8, that looks normal. 9, that's not normal. That should be like 1.15. So whatever's on pin 9, there's a problem. Gotta look into that. 10, 9 and 10 are both like that, 1.1 something. 11, 12 is no connection. 13, 14, 15, 16. What is connected to pin? Okay, well now it's back up there. Okay, now it's reading. Yeah, the reading has changed. So I have caused something to get triggered or enabled or disabled. or I discharged. There was 13 volts still across these big filter caps. Probably a little bit right now, and that can skew your readings. Right there, 17 volts. They will sometimes build up a little charge. We're just going to see if we can get rid of that. We'll discharge it, and it will probably come back. It's just kind of an attribute of electrolytic capacitors. Check the voltage now. I see it climbing. They do that. They just kind of, they do that. So we know we need Q34. I just doubt that that's all of it. Because in the past, that would just make it shut off. What are the odds that we've lost that Zener? Doesn't seem to be bad, though. Oh, I'm in voltage. I was wondering why my diode mode didn't work there. Okay, that doesn't seem to be shorted. And these 7.5 megohms, they're just not gonna cooperate in circuit. I do have some of these. Yeah, 300 megohms. But the only way to do it is to lift one end of them. See, now we're getting negative resistance. Anytime you see negative resistance on your meter, that means there's voltage present. And it's pushing current through your meter in the wrong direction. The meter is trying to supply current, and there's current being supplied from a capacitor on the board too. So yeah, just about impossible. I may lift those and just see if they're still good. But if you think about it, it's hard to destroy a 7.5 megohm resistor. Not impossible, but I mean, it's hard to get enough current through a 7.5 megohm resistor to burn it open. It's just because there's very little current going to flow through that. Probably time to get the microscope back out. Alright, well, I have replaced the blown MOSFET. I believe it was Q34. And I also went ahead and replaced that Zener diode, ZD. Looking at where that, where that insect had crawled and shorted, basically it looked like about 400 volts would have gone straight to that Zener diode and straight to that MOSFET. Basically, he bypassed those two 7.5 megohm resistors. And nothing can end well when you do that. So I went ahead and replaced that Zener because it had to have taken a hit. And the MOSFET's replaced. And I think we're ready to test. I am connected this time. I'm going to connect my load back up here. Yes, positive on the inside, negative on the outside. I do have a meter across the capacitor here, the boost capacitors. I want to know how high that voltage is getting, if it's getting dangerous or not. And I'm going to turn this load on. It is set for 10 amps. So let me turn that down. I turned it down because this AC variable AC supply I'm using doesn't have a lot of current capacity to it. I do not want to overload it. Okay, so we'll be able to see the get the scope out. We'll be able to see the DC voltage here if it comes up, and we'll be able to see the boost voltage across these filter caps right here. And I am going to bring it up slowly, and let's see what happens. You know, nothing happened because I didn't connect the AC. Take two. All right, the AC is just on, but it's turned all the way down. Let's try it this time. Yeah, we're seeing. I was wondering why I wasn't seeing any rectified DC voltage coming up here. That can explain it. 60 volts AC, somewhere around 70 or 80 AC it'll start trying to kick off. Still trying. Oh, there it goes. Okay, we're running. Interesting. We are running. We're getting 11.93 over there. 396 volts across the load. I mean, not across the load, I'm sorry, across these filter caps. So that's basically your PFC, boosted voltage. Okay. Interesting. Okay. And that is with a 5 amp load. All right, I think we made some progress here. Let me run a few more tests on this thing, and we'll just see if it's all good. We'll put it back out there in the chassis. Give it a test on a real PS5. See what we could do while I'm here. As long as we're here, let's turn this off, and we'll go straight into the outlet back here. 396, 11.93. I'm going to increase the load. So I can only go so high when I'm running it off of that variable supply. It has a 2 amp fuse on the output. You can see the label there on the front. Isolated 2 amps. It's a slow blow, but still, I've blown it before. All right, that looks good. Let's bring it on up. 16 amps. Rock steady. The voltage looks low there, but it's not that low. That's lost across these leads. If you put a meter there, it'll be right at 12 volts. So don't let that throw you off. We are drawing 16 amps through these wires, which they're not small wires, but they're not huge either. Should we bring it on up? 20 amps. She's still working. All right. I think she's going to work. Well, here we are back out in the garage. This PS5 is fully reassembled with our repaired power supply. And I've installed a game off of Blu-ray. It seems to be running it just fine. And I think it's going to be, it'll work great from here on, I believe. I did want to, before I sign off, I wanted to mention early this morning, before I got out of bed, the channel went over 10,000 subscribers. And I definitely wanted to give a thank you to all of you out there who have supported me. And I'll try to do my best to bring you some more content really, really soon. Well, I hope you thought that was somewhat interesting, educational, entertaining, any of the above. If you did, please give me a thumbs up. And I'll see you in that very next repair. Bye for now.